Welcome to yet another video on SRID Cloud. In this this video, I want to talk about redundancy for networks. This is the continuation of my previous work. Refer to my earlier video on how BGP and outbound NAT operations can be accomplished across the data center and an external network. So in this video, I extended the same topology with another edge router. So there are two edge routers in this topology, and if one of them go down, the other one will pick up the continuity of the connectivity. So let's get started. Let's take a look at the compute nodes that are connected to the switch on the data center side. For the sake of completeness of this video, sorry, you don't have to refer to my earlier videos. So let's go to the PC1, and its IP is set to 10.144.45.2. Let me make this bigger. So 10.140.45.2, that is IP of this compute node. And there's one more called PC2, and its IP is set to 10.140.45.3. And these two are connected to VLAN 1000 on this switch. And the switch in turn is connected to the router, the core router. And there's a port channel on it. We're going to take a look at it, and that will be the gateway for this tiny network. And our intention is to make this network talk to the external network using NATing. And there is another network, 10.140.50 on VLAN 200 on the data center side. And here is a compute node on it, and its IP is set to 10.140.50.2. And there is a router for this network as well in the core router. So let's go to the core router now. Let me make it bigger. So now let's take a look at the running configuration. There is a VRF defined in this router. Let me make this here. And the ASN number of this router's BGP process is 65999. Let's continue to look at the rest of the running configurations. There's a port channel number 1, and it has two sub interfaces, one for VLAN 1000 and one for VLAN 200, and their IP addresses are set accordingly. The 10.140.45.1 for the VLAN 100 and 10.140.50.1 for VLAN 200. And then there is a port channel 2. This is for the northbound connectivity to the edge router, and actually both of them. There are two of them now, and there is only one sub interface on it for VLAN 1000, and its IP address is set to 172.16.16. So in between the core router and the edge router, there is a transient network 172.16.1.4/30, and the IP addresses are .6 and .5 on either ends. And then we wanted to implement the redundancy, so we have another edge router here, and that is on a 172.16.10/30 network, and the IP addresses are .2 and .1 on either side. So that is what this is, port channel 3, and its sub interface is port channel 3.1001, and its IP is set to 172.16.1.2 on the core router side. And then the Gigabit Ethernet 1 has this channel group setup, so that port channels are associated with this physical port, Gigabit Ethernet 1. And similarly, the gigabit Ethernet 2 facing the edge router, the first edge router, the northern edge router, and that is on channel group 2. And there is another physical port, gigabit Ethernet 3, and that has the channel group 3 on it. So gigabit Ethernet 1, 2, and 3, they all carry the corresponding port channels and sub interfaces. And here is the BGP setup. Both 172.16.1.1, which is the southern edge router, and the 172.16.1.5, which is a northern edge router, these two are the neighbors of this core router, and they're all defined here. And we are passing along the 10.140.45.0 and 10.140.50.0 to the edge routers with the BGP configuration. And I think that, there are a couple of default routes from the core router. One default route is to the northern edge router, and another default route is to the southern edge router through 172.16.1.1 and 1.5, or I should say 1.5 and 1.1 respectively. So that is what we have on the core router. Now let's go to the northern edge router, and that is this one. Let me make it bigger. So this one should be somewhat familiar to you if you watched my earlier video. This is exactly the same thing, but let's look at the configuration anyway. So there is a customer VRF that is facing, let me move this over, facing the external router. So there is an interface gigabit Ethernet 2 towards another switch on the customer side, on the external network side, and that is on customer VRF. And there is a VRF A which is to the core router. So that is on VRF. So for this purpose, we have customer and VRF A VRFs. And to do the route target imports and exports so that BGP can distribute the routes across, we have route target import and export mechanisms here. So now let's go and take a look at the interfaces. This is the port channel 1. Port channel 1 is towards the core router, and it's on VLAN 1000. 172.16.1.5 is the IP address of that port channel on the edge router side. The northern, we are looking at the northern edge router right now. And then gigabit Ethernet 2 is directly, without any port channels, is connected to the external router on the other side. So that is gigabit Ethernet 2. And it carries the IP address 10.140.12.141. That is the interface IP address for the northern edge router. And IP NAT outside is also defined here. This is for NATing operations, which we will see in a moment. And 3 and 4 are kind of not very much used. And for inter-VRF NATing, we have this WASI left and right configurations. The WASI left is on the VRF A on the southern side, and customer VRF on the northern side towards the external router. And here is a BGP setup. There are a couple of entries here, one for customer VRF and one for VRF A VRF. On the customer VRF, there is a 10.140.12.129, which is the IP address of the external router, and its ASN is 67,000. And we only pass along the 10.140.50.0 network on this BGP. That's what we want. We do not want to do the 10.140.45.0, which is going to be NATed anyway. We do not want this route to be distributed. And similarly, on the VRF A side, 172.16.1.6, which is the core router, that is the neighbor, and the core router's ASN is 65,999. The 66,999 is the ASN of the northern edge router. And then we have the usual ACL that will permit only 10.140.45.0 NATing network that I was talking about to go through the NATing operation, and the host is defined as 10.140.11.4 on the external network. So only traffic coming from 10.140.45.0 is allowed and only able to go to 10.140.11.4 on the external network. No other traffic is allowed. And there is a pool, NAT pool. I derived 10.140.12.150 IP address from the interface, from the tiny network between the edge router, the northern edge router, and the external router. Remember, that is 10.140.12.128. From that network, /25. From that network, I derived .150 IP, and I'm using it for NATing purposes. And then here is the NATing operation, IP NATs inside source list using the pool and ACL that we just created. And the NATing is defined on the customer VRF, that is towards the external router. And then there's a default route in the customer router towards the external router, and there are a bunch of WASI left and right routes defined to facilitate the traffic flow between the VRFs, VRF A and customer. And let's see if we have anything else. And there should be nothing else in this router. And this configuration is duplicated on this southern edge router. So let's take a look at it anyway. But only the IP addresses are different. Make it bigger. So whatever we saw earlier on the northern edge router should be duplicated here. So here is the customer and VRF A VRFs. Route targets are imported and exported, or exported and imported. And then there is port channel 1 and port channel 1001 towards the core router. And the Gigabit Ethernet 1 is on it, and Gigabit Ethernet 2 is directly on the customer VRF without any port channels, and its IP is set to 10.140.12.140. So this is what I'm talking about. So this is 140 and this is 141, as we saw earlier. There's a difference between these two routers, and IP NAT outside is defined on this interface towards the external router. 3 and 4 are not used at all, and this is the WASI left and right, which we saw earlier. Same thing, but only thing is, it should be identical. And here is the BGP on the southern edge router, and its ASN is also set to the same 66999. So it is possible to have the same ASN on both routers in this redundancy topology. And I derived that, here is the BGP configuration for customer VRF and VRF A. The same IP address 140.12.129 is used for the connectivity to the external router, and 172.16.1.2 on VRF is towards the core router. And if you remember, on the northern edge router, this IP, the neighbor IP for the VRF A, was 172.16.1.6. That is this one. And for this router, the neighbor is .2, that is facing on the Gigabit Ethernet 3. So Gigabit Ethernet 2 is connected to northern edge router, and then Gigabit Ethernet 3 is connected to southern edge router. So that's what this one is. And then the same thing, the same ACL configuration here. Here, if you noticed, the pool, I did not reuse the same 150 IP address here. I used 151. There's a reason behind this. If I use the same 150, then the natted communication may go through northern edge router, and the return trip may come through the southern edge router, and that will cause problem because the NAT configuration with IP address 150 is defined on the northern one, and then if the same is defined in the southern, then that will cause a conflict. So because of that, I used a different IP address for NATing purposes, 151. I believe this is very, very important. Otherwise, we will run into some unnecessary issues. And then everything else is same that we saw earlier. There should not be any difference at all. And that is it. So now, while we are here, let's look at the routes. Show IP route. There should be nothing in the global table. Show IP route VRF customer. That should show the BGP networks across the core router and then the external router. And similarly for the VRFA, so this is how it is configured on this side. Let's go to the northern edge router again and then take a look at the routes very quickly. There should be nothing in the global address table. So this is how the BGPs are enabled and routes are distributed under the customer VRF, and VRFA is the here is the routes for the VRFA. So okay, now let's go to the external router and then see how that is configured. This is not it. Should go to the number 3. Okay, here it is. So this is a very fairly simple setup on the external side. There is no port channels. There are no VRFs either. So here is the Gigabit Ethernet 1 that is connected to the switch, and it is further connected to both the edge routers on the same network 10.140.12.128/25. If you noticed, this 10.140.12.128 acts as a transient network between both the edge routers and the external router. The IP addresses are 129 here and 141 on the north and 140 in the south. So all 3 IP addresses belong to the same network. And Gigabit Ethernet 2 is for the southern connectivity to 10.140.11.0 network. And this 10.140.11.1 acts as the gateway for the 10.140.11.0 network, on which we have a compute node as well, the 10.140.11.4, which we will use for ping testing purposes. And Gigabit Ethernet 3 and 4 should not have anything. And here is the BGP. This BGP is configured to talk to both neighbors. The north and south edge routers both are configured here, 1 through 140, which is the south, and 141 is for the north. And that's it. There is nothing else. Okay, now let's with the both routers alive, the north and south alive, let us do a ping test from PC1. And let us try to ping the external network, a compute node, ping 10.140.11.4, and it works. And now let us see which of these 2 routers is serving this NATing configuration at this point. For that, we need to first of all go to the core router and look at the BGP on it. And if I say show IP route VRFA. So the network 10.140.11.0 is connected through 172.16.1.5, which is the northern edge router. So right now the traffic is moving from the core router to the external network through the northern edge router. So this is the northern edge router. Let me do it again. And if I do the translations, I should see a lot more now. Okay, so at this point, the traffic is flowing from the left to right through the north edge router. Let's do one more test. Let us go to this PC3 and try to access this BGP network 10.140.50. I think I already did that. So here it is. So the PC3 on the external network is able to talk to the 10.140.50.2 via BGP, not through NATing. And similarly, if I go to PC4, and I should be able to ping 10.140.11.4, and it works. Okay, so now things are going well in this network. And what if the northern edge router goes down? So I'm going to force it. I'm going to shut down the northern edge router, and everything should now flow through the southern edge router. Okay, so now let me shut this down. And now what we need to do is look at the core router. And also the external router. There's a reason for this. Let me explain in a moment. So I'm going to watch these two, and there should be some messages in these two routers saying that the router, the northern edge router, has now gone down. So both the core router and the external router should get notified of this, and they will gracefully switch over to the southern edge router. So that is exactly what I'm trying to do. I'm going to close this. So let's wait. There should be some messages in these two windows that basically this .5 neighbor, the 172.16.1.5 neighbor of core is down, as well as the 10.140.12.141 neighbor of the external router is also down. So these two notifications should go to core and external routers, and they should switch over to the southern edge router. So let's wait for that to happen. And while we are waiting, if I go back to this PC1 and then try to ping, it's not going anywhere because the connectivity is now broken. The environment has not switched over to the other router yet, the southern router yet. So let's wait. While we are waiting, I can always look at the route. And it is still pointing to .5, which is the north. And here also, if I look at the route, this is what I should be watching, sorry. Yeah, so we got the messages on both the windows. So this is the core router, and core router got a notification saying that the 172.16.1.5 is no longer a valid neighbor. That is, if we go back, this 1.5 is no longer a valid neighbor of core router. And similarly, on this side, the .141 is no longer a valid router for the external router. So that means for this router, 141 is no longer a valid neighbor. So what does it mean? did it switch over to the instead of dot 5, it should have switched over to dot 1. Let us see. And as you can see, it has switched over. The 10.140.11.0 is now switched over to dot 1. That means the traffic to the 10.140.11.0 now will flow through the southern edge router. Similarly, let us look at the external router and see what he has done. And as you can see, the connectivity is now gone to 140. Here it is. 140 is the southern router. So now let us see if the pings work. Let me go to PC1 and then try to ping, and it works. And similarly, let me go to PC3 and ping the BGP network, and it works. And let me go to PC4 and see if it can talk to the external network, and it does. And now let us see where the IP NAT translations are taking place. This should be now done under the southern edge router. So let me ping this IP again and then look at the southern edge router. And there they are. So now this is how the redundancy works. Now I can bring the northern edge router back in business, but the environment may not switch over to that because there is a running active traffic flow through the southern edge router. So why switch over to the north if I even switch it on? Let's say, for example, let me turn this on. Even if it comes back alive and working, unless and until the southern edge router goes down, the switch will not happen, and it need not have to happen. So this is a proof of this use case that I have a couple of networks on my left inside my tiny data center, and it is connected to an external customer network through two different edge routers, north edge router and then southern edge router. And this redundancy will increase the confidence in the data flow between these two networks. If one of them go down, the other one can always pick up. And obviously, if both of them go down, then that is the end of the story. So I hope you liked this video and understood how the redundancy is implemented in a fairly complex way. Not only BGP, but also NATing is also implemented in this topology. And thanks so much for listening, and I will produce a lot more videos in near future on various topics. And I will see you all very soon, and have a wonderful day or evening or good night. Bye for now.